way we do our agriculture will affect the other, will be important in affecting the global aspect. So you've got the carbon cycle. I'm not going to go too much into it, but you've got carbon is needed for anything. Life can't exist without carbon. And where it is, changes, obviously it changes form. Carbon, the CO2, is a form that's actually dangerous and detrimental to what we, if it's too concentrated, to what we have, for our survival. So it's basically, it's good to have carbon, but it's in the form that becomes a danger. Same with the nitrogen cycle here. I don't need to go into that. Then we're going to soil food web. So this is primarily for our agricultural techniques, which are largely responsible for where we are today in the world. Once we understand how the soil works, so it's a symbiotic relationship between the organic matter. So the plants exude exudates, which are like sugars, carbs, and so forth, to attract the different types of bacteria, which then attract the fungi, the protozoa that it needs, and the waste from these is what's going to feed the plants. So unless you have the bacteria to attract the right second level creatures, shall we say, the plants then, that's how the plant system works. 80% of the immune system is from the plant. So if we destroy our soils, which we're doing with modern agriculture with chemical inputs and so forth, you're going to have weak plants, which then means you're going to need pesticides and herbicides and all that. So it's super important to actually understand that the soil is very, very important. It has a holding capacity for water. It produces, it gives the nutrients that plants need to have a healthy fruit, which then passes on to us. So it all starts there, and it's all a matter of a symbiotic relationship to the animals around as well. Patrick showed me the mycelium growing on the coffee grounds. That's the mycelium there, which is basically a network, and this is actually in forests, in old growth forests and so forth, it's actually able to transport sugars and carbons and different nutrients between different species. It's also acting as a network of communication as well, interspecies communication. So, for example, if some invasive species is harming the plant, through this network it's going to warn the other plants of the same species further on down, either through the mycelium network, or it's going to exude certain chemicals that will then be detected if the wind's this way, obviously, and they will then start producing protective layers for so it's a whole symbiotic relationship, the way it functions. So the more we understand how the world is functioning, the more we know how to take action to protect it. Again, this is the human microbiome. We're trying to be as sanitized as possible, maybe not the best ideas, because without the bacteria in our gut, of which there are thousands of species, and the different areas of our body, we would not be able to survive, because it's the bacteria that digests the food that provides the nutrients to our body. If we were to eliminate this one step, we would actually die. And in the same form, we can say the same thing for the plants. And in both cases, the immune system, about 80% resides in the root system, and also in our gut system, the same for us, for humans. So that's how important the symbiotic relationship is. Coming back to the carbon cycle, this is very important, is the geobiology. So here we have a small carbon cycle, and then we have a very large carbon cycle. Right, so the small carbon cycle is more your trees, your forests and so forth, which is it's a cycle where the carbon stays in the ground or secured for maybe 25, 50, 100 years or so forth. However, if we're looking at limestone and dolomite rock, you can store it for thousands, if not tens of thousands or hundreds of thousands of years permanently, which is what we actually want to do since we have excessive carbon. And so if we study this type of understanding, then we can realize that Cyprus, there's only 4 places in the world where actually on the surface we actually have peridotite, which is basically, you can actually put it on the surface of the land and it's going to start sinking carbon and actually hold it for thousands of years. So this is actually an easy business model for Cyprus if they want to use that as carbon credits or as a new type of business. It could be, they could be making surfaces of buildings out of this material, right? So they're actually using carbon sinking. It's a new business that could be created.
So it's some kind of stone? Or?
It's a stone, it's like limestone.
Okay.
It's like limestone. It naturally, because of its chemical structure, it actually absorbs and reacts with CO2.
Right.
And once it's reacted, it stays. So
Yeah.
it doesn't release over, like a decomposing tree, it's going to release it again.
Yeah.
When you rip up the soil, when you're tilling the soil, that's releasing carbon dioxide again,
Yeah.
back out into the atmosphere, which is another reason why we shouldn't. So for Cyprus, we're looking basically at different approaches. So we can't just go into community and industry and work just like on one section, but we actually have to look at all the different systems around. So whether it's forestry, whether it's agroecology, which is farming, industry, and then also the marine, because as we're an island, that's also important. So this is something that I brought in from China, who they had a very good project and good results from, it's called the Lus Plateau in China. It was the most eroded place on the planet. It's also the origin of Chinese history, all originated from there. It was that for the last 1,000 years the poorest place in China. It had what's called the Yellow River, so all the sediment that was such a fine dust, as Lus is a type of material, like a soil structure, was actually being washed in the rivers. The rivers would then flow downstream, become like muds, you can actually walk on it, and there'd be a lot of floods and so forth. So what they did is they actually decided how to work with the locals. It was about, I think, 2 million people involved. Area was 35,000 square kilometers, and over 10 years the results are absolutely phenomenal. It's like night and day there. They have water secured 24/7 and food production, they've tripled their income and so forth. So in the same sense, I've used that kind of approach in our example here. So what they did is they actually zoned the areas, anything beyond 25% gradient. They actually said, okay, this is now going to be untouched, we're going to grow our forests there, it's going to be no-go zone for humans. So that's going to be zone 1. So here it's basically, you're going to use this area. So we have zone 1, which is your like mountainous area here, to plant, let's say, indigenous types of trees, or trees that actually work well, since indigenous trees there are non-existent, since they've been replanted before. And off limits to humans and domestic animal use. So no grazing, no grazing, no hunting, none of that is going on in these areas. So this is actually going to be your water capture system, shall we say. We'll see how we can do that pretty easily. Zone 2 is your productive ecology. So the flatter plains that you have, basically you can use your agroecology systems, which is used also for water capture. You can have your food forests, integrated farming techniques, and agro-production. So that would be like where you're creating food systems that will be obviously feeding the community or the rest of the island. Zone 3 is your rural village. So rural villages, again, you can actually start eco-industries there. You can have zero waste asset homes for quality living, water capture again, energy production, storage and resilient economic activities. And we'll go into what those could be. And then zone 4 is the sea, which is hardly visible, but it is there. This is areas that are now no fishing zones, and you can actually create a lot of productive systems underneath the sea. So zone 1, this is basically your polyculture indigenous trees. So you never really want to go with monoculture. You can see this is all monoculture. It's all like pine type of trees. This obviously is not very biodiverse. You have root systems that are all going to the same depth and using the same type of minerals, and so you don't have very healthy soils nor forest, so they're going to grow slower. So that's what you want to change if you're redoing these areas. Water capture techniques I'll show you later. Reintroduction of local wild animals. Again, that's sometimes takes its natural course, but sometimes we can help with that as well. Nature reserve area, so again, no hunting, and increases soil organic matter. So soil is super efficient at capturing and absorbing water and also releasing it slowly over time. So even if it's, you're in a drought period, you'll still have water coming down your little river or streams, which then keeps the wildlife alive. So 1% increase in soil organic matter can absorb up to 150,000 litres per hectare. So if you have 50,000 hectares, you've got a dam worth of or more of secured water. Enhance fertility and reduce nutrient leaching and so forth. So inputs and outputs. So you can actually use, for example, military youth who are in training. They can actually participate in reforesting. The forestry department jobs are going to be there, volunteers bringing in EU funds and atmospheric carbon sequestration. And the outputs again is oxygen. You can have products, so you can actually grow fungi, bees and their value-added products, and you can also have products coming from the actual forest. It could be also research opportunities, educational tourism, creating a microclimate, and social development, so you're educating the youth. So these are things that can be implemented there so that you're using it for more than just one function. So this is the case in Slovakia. The government for a year and a half funded a project that had amazing results. So basically they had water issues, and they had a choice of either building a dam or actually trying to secure water through soil, and they chose initially the soil, and they changed from making a dam. But they had 42 million euros of investment, and they created 100,000 pieces of water retention measures. Now, what are these? These are basically very simple. When you're planting a tree and it's on an incline, you're just creating a dip so that water can actually sink in there. It's very small, very simple, non-technical, and long-lasting impact. These small little changes that they had, like slowing down rivers, right? So something from this where you have all the runoff going and all your sediment and all your healthy soil being run off, placing up, slowing down, sinking the water. Here again is the before and after. So the pics, 1995, 1997. So this is what they were working on, creating that. From that they built it, and it became like this. It's almost non-recognizable, yet it's slowing down a lot of water, it's sinking, it's creating from very, very little vegetation, it's created this whole new ecosystem here. And all it is some wood placed in place of a and again, the results are you having a lot of soil retention and no runoff, or very little runoff of soil. So it's proven. This is not something that we're trying to invent or what we're doing. We're borrowing it from a real case study. So again, we go to zone 2, which is a productive agriculture. Here we're looking at, again, using non-tilling or very shallow tilling methods. Agroecology, design techniques, so you're intercropping, you're using beneficial herbs or flowers that attract a certain type of pests that we're going to be rejecting, the harmful pests and so forth. Integrated farming, so I'll show you what that looks like. So you're having, let's say, wildlife going within your could be fruit crops or whatever you're growing there. So you're integrating with different systems. What they're helping, because of their weight, they're helping to break up the soil, to leave indentations. So when it does rain, it actually stays there. And they're also fertilizing as they do that, and then clearing also the weeds or whatever. So that's a multifunctional approach. So, for example, this is in France. Instead of having a straight wheat field, you're actually intercropping with trees. So your trees, they're acting as a windbreak, so you have less evapotranspiration. They're actually pulling in, possibly if it's a type of tree, they're going to be pulling up nitrogen from the soil, which then creates a much more healthy soil, so your crop actually grows. If you have, let's say, for example, hail, this will help prevent damage to the crops. So there's just multiple benefits that can come, and your production actually, if you look at, so basically if you're actually looking at the two systems together, the two systems apart, this is, let's say, modern, up here, monocrop, then you have palm oil. They're just comparing the two. Let me just see here, palm oil, forestry, palm oil, plot 1, plot 2. So they've increased the number of number of plants per hectare. They've increased it, so they're more intensive. Right, so I'm not quite sure what I was doing there, what I thought there, but anyway, I'll have to look at that again. So also the other aspect here is if we have solar farms in Cyprus. So you have a field, you put solar panels and stuff, but you can actually grow within there and actually have an increase of yield for between 1.3 to 1.7. So you actually, if you had basically a field only of this crop or a field just of solar panels, you can actually produce more with the hybrid. And of course, they're helping to shade in the very hot summer months there, and they're keeping this cool, so this is operating at the coolest temperature and also getting benefits from there. Again, we're looking at inputs and outputs, so again there's a multitude of inputs that can help. So if you have, let's say, unemployment and so forth, you have a lot of opportunities to get people working if they want to work, and involve different bodies, universities, agricultural department, and coming out, you've got, of course, your oxygen, you've got your aquaponics if you need it, produce, and so forth. Again, a lot that can be produced from changing the operating system there. Zone 3, again, we're looking at, this is your rural villages, so smaller communities. You can create ecological industries from there. You've got animal grazing, so your animals are kept within certain areas, so that's where these would be happening, or with Zone 2 as well. Water capture, mini dams if you want, and yeah, there's a lot of opportunities, because it's, again, we're looking at working things differently. So then obviously it becomes educational and creating new opportunities in space there. So these are like, you got your aquaponics, which is farming, fresh veg. We're using it's a hybrid between two systems: aquaculture, which is fish farming, and hydroponics, which is growing without soil. So you marry the two. Both of waste streams, both are toxic, harmful to the environment. But when you connect them together, you actually have a closed system.